So if we are looking at positive or negative correlations, if there is some sort of trend in that information, in that data, there should be a line of best fit or a trend line that we can use to represent that data. So here we have a scatter plot on the right-hand side of baseball ticket prices. And you'll notice that there are some points plotted, and then there is a line drawn. That line is the line of best fit. As you notice, the dots or the points don't actually all hit that line. So that line is kind of representing the best estimate for an equation that would represent those ticket prices. So what we want to look at first is if this is a positive or negative correlation, and it is going upward, up and to the right. So we would say that this is a positive correlation. And we are going to find an equation to represent that line that is drawn on the scatter plot. So in order to do that, we are going to use 2 points that are listed here for 1998 at 13.6. That's the price of the ticket, $13.60, and 2003 and 19. So those are showing years. And if we look at our graph, it starts at 0 and then jumps to 1997, then 98, 99, 2000, 2001, and so on. It might be easier, instead of dealing with large numbers like 1998, 2003, is to turn these numbers on the x-axis where the years are into single digit numbers, or more manageable numbers like 1, 2, 3, and 4. So we're going to say that 1997 is year 1, 98 is year 2, 99 year 3, and so forth, going down the line. So each year we just add 1. So year 1, 1997, year 2, 1998, and so on and so forth. So that means our coordinate that we're going to be using, this 1998 13.6, is really 2, 13.60, and that's okay. And then our second point is 2003. 2003 was a 7, so 7, 19. So I'm going to be using those numbers to help me write my equation in slope-intercept form. So just a reminder, slope-intercept form is y equals mx plus b. So we're going to need to find our slope, m, and then we'll need to kind of determine or ballpark what that y-intercept is. If you look at the graph, it's around 12, but we can't be 100% sure what that number actually is. So we are going to have to find out what it is based off of these 2 points. And again, this is a line of best fit. If you picked 2 other points, it's going to slightly change the equation depending on the location of those points. So keep that in mind, is if you change the points, it is going to slightly change the equation. But this is going to be the line of best fit based off of these 2 points. So the first thing that we're going to do is find our slope. So again, slope formula. So y2, which is 19, minus y1, 13.60, over x2. You can use the 2003, but I suggest using 7, smaller numbers, minus 1998's number is a 2. So 19 minus 13.6 gives me 5.4, over 7 minus 2 is 5. And that gives me a slope of 1.08. So our m, our slope, is 1.08. And then I'm going to use point slope form to help me find my equation in slope intercept form. So just a reminder, point slope is y minus y1 equals m parentheses x minus x1. So I will plug in a point for x1, y1, and I'm going to plug in 1.08 for my slope. So y minus, and you can use any of the numbers. You can use 2, 13.60, or you can use 7, 19. It does not matter. I'm just going to use the first one. So y minus 13.60 equals our slope m, 1.08, parentheses x minus 2. And then I'm going to transition this into slope-intercept form. First, I am going to distribute that slope into the parentheses. And we have y minus 13.60 equals 1.08x minus 2 times 1.08, which is 2.16. And then lastly, we are going to add 13.60 to both sides. And y equals 1.08x, and 13.6 minus the 2.16 gives us positive 11.44. So our equation in slope-intercept form, representing our best line of fit, is y equals 1.08x plus 11.44, meaning our initial ticket price, year 0, would be $11.44. Now what we want to do is predict the price for part C here. We are going to predict the price of the ticket in 2009, because we can kind of see where the trend is going, but 2009 is no longer on my graph. So 2009, we need to figure out what year 2009 would have been. So 2006 is year 10. So you can do this. 2007 would be year 11. 2008 would be year 12. And then 2009 would be year 13. So I'm going to use 13 as my x value to find out what would happen in year 2009. Again, if you had originally wrote this equation with the 2003 and the 1998, that's fine. And you could do all of this with those numbers. We want to deal with some smaller numbers, so we're going to turn them into 1 through 13. So for x to equal 13, we're going to plug that into our equation and find out what the ticket price was. So y equals 1.08 times 13 plus 11.44. And I'm just going to plug this into my calculator to find out what that ticket price would be. So 1.08 times 13 plus 11.44 gives me 25.48. So in 2009, the price would be $25.48, most likely.